let's do a mic test. Can you guys hear me? Okay, I can hear myself, which means you guys can hear me. Okay, so awesome. All right, guys, welcome to today's tutorial. So we're just going to be looking at some simultaneous equations today because that's been a bit of a request for the last few sessions. So this question was actually sent, as you can see, by somebody. I can't remember who it was. I think it might have been Jonathan. I think it was Jonathan. But anyway, what I'm going to do is I'll show you guys the type of questions that we're going to be doing today. So there's going to be about 5 questions that I want to focus on. And then after that, I'll just kind of leave, depending on how much time we have. We can actually look at some other questions as well. So the first question, we're going to be looking at this particular one here. And then a second one is, another big word question there. But I don't think this one is a simultaneous equation. It's just a linear equation. But the wording, the way the question is actually asked, it's kind of good to just understand how to actually write linear equations, which of course is going to help you with simultaneous equations. The third question that we have is this one here. This question I actually chose because there was a question like this in 2017. So this was actually very similar to a question from 2017. That's why I thought I'll bring this question back just so that we can actually have a go at this question again. Now this particular question, I think it was in 2016 or 17, I can't remember, but I kind of just looked up for some simultaneous questions, and I know this question caused a lot of grief for students, so I'm going to spend some time on this one. And of course, my last question is Sparkles the Clown. Yeah, so this question is a very straightforward simultaneous equation. So this is the second question we're going to be looking at. All right, as usual, guys, if you do have other questions, just feel free to kind of ask in the chat, and I'll try and keep an eye on it so that I can actually answer questions along as well. And also, I will have just need to double check my, keep my Facebook here open. So if there are other questions, if people want to pop and send it to me, they can send it as well. Let's see. We're good. Okay. Yeah, all right, Dominic, I just saw that question. Give me a second. I might just add it up after I finish all these 5 questions. Okay, so let's go to this first question from Jonathan and kind of get things going. Okay, so what we have is we've got Sylvester here. Who cares about Sylvester? But he's entering a maths competition in which there are 50 multi-choice questions. All right. So basically so he's got 50 multi-choice questions. The second part to look at is every correct response, he actually gets 9 points. Okay. And then every incorrect response actually gives him 5 points being subtracted from the total. Yeah, welcome, Eliana. So then what we have is if Sylvester attempted each question, so we know that he's attempted each question and ended up with a final score of 2. Okay. So how many questions did he answer correctly? So we've got to try and figure out to set up a set of simultaneous equations. Now the first thing I'm going to do is I'm going to write down here that C is the correct response, and I could do I as incorrect response. All right, so that's just me kind of saying that, kind of putting a letter to the variable. All right, and that's really important especially when you're doing simultaneous equations. Don't just go X and Y. It's a really good idea to kind of show what each letter actually represents. Okay, so what we know is this: we know the first thing is, and I guess this is a way I kind of teach my kids how to do simultaneous equations, is I actually ask them to create like a little table, like something like this. All right, just if you want to have a look at this. So what we have is C is it's the number of correct responses that he actually has. So that's going to be C. I is the incorrect questions. So if you look at the correct questions and the incorrect questions, the total of that is actually 50. All right. And then the second one is he's actually got a score. So this is actually the number of questions. And then this is his score. Now for score, he gets 9 points for every correct response. So that's going to be 9C. And then I is incorrect response, and he actually gets 5 points being subtracted. So it's actually going to be 5I. And then his total score is actually 2. Azhar Sadiq. Now, why does that name ring a bell? Man, shouldn't you be like done with level 1 by now? Okay, anyway, so let's go to the so basically this table here is going to give me my equation. So my first equation I have is C plus I equals to 50, and my second equation is 9C minus 5I equals to 2. Hi, Connor. So once we've got these two equations set up, it's from here, it's kind of like there's a couple of ways you can do this, guys. Like you can do it in you can do elimination, you can do substitution, you can do rearranging. Now just for this particular question, what I'm going to do is I'm going to show you guys both, like a couple of ways to kind of do it, and then you guys can actually figure out which is easy and you can go with that. Now it's really important to know, guess and check will not be it won't give you the full marks for these questions, for simultaneous equations. Generally speaking, if you actually do write up 2 equations, you can actually get an achieved grade. But if you guess and check the answer, I think you're still only going to get achieved. How do I get 2? If I go back to my question, where is it? This is where I get, so he's got a final score of 2 right there. Maybe I should use a different color there. So final score of 2, so that's where I get that 2 from. Yeah. Okay, so anyway, once we got this, so the first method I'm going to do is I'm going to do rearranging, just to show you guys the different ways of doing things. Okay, so with rearranging, the first equation I have is C plus I equals to 50. So I'm going to rearrange it, and I'm going to rewrite that as C is equal to 50 minus I. Let me just put that in a different color. All right, so once I do that, what I can do is I can go to the second equation. The second equation is 9C minus 5I equals to 2. All right, which means I've actually just said what C is equal to. C is actually equal to 50 minus I, which means I can replace the C in the second equation with 50 minus I, and that's what I'm going to do. I'm going to rewrite this as 9, 50 minus I. Man, this is looking a bit messy, unless I made a mistake somewhere. Yeah, we'll see what happens. Minus 5I equals to 2. All right. So then when we do this, 9 times 50 is going to be 450, and then 9 times I is minus 9I. Then we've got minus 5I, and all of that is equal to 2. I hope you guys are okay with that. So then what we have is 450 minus 14I equals to 2. I'm going to rearrange so that I is by itself. So I'm going to have 450 equals 2. This actually ends up being plus 14I because I'm switching over the signs. And 2, when I bring it over to the left-hand side, it would become minus 2. And that's 14I. So what I've got is 448 equals 14I. All right, so which means I got to go 448 divided by 14 equals I. No worries, Wonka Vision. I'll be doing some calc tutorials later on. I'm just getting the level 1s done, and then I'll get to some year 13 calculus later on. Okay, so we got this number 448 divided by 14, and yes, we've got to actually do this without a calculator. Now you're sitting there thinking, oh my god, this is just really annoying. How am I supposed to do this without a calculator? So I'm gonna show you guys a couple of little tricks here. Like, I mean, I guess the way to kind of know is like, just know, even if you don't know your times table for 14, I'm just going to show you guys some tricks. All right, when you have 14, you know 14 times 2 is 28, and another 14 is actually 42. All right, so the way I'm going to show you guys is that this is how I'm going to show you guys how to do it real quickly. So you just chuck a 0 at the end, and what this becomes is 420. All right, and then what you have is 14 plus 14 is 28. So I'm hoping you guys can see 420 plus 28 is actually 448. And how many 14s we've got? We've got 3 lots of 14s here, which is 30, and then here is 2. So what you're going to get is 32 equals I. Now, you don't need to actually use this method. If you actually know how to do if you're comfortable with doing it your own method, that's absolutely fine as well. I mean, I'm just kind of messing around with numbers here. All right, so I is equal to 32. Now, if you go back to the question actually says how many questions did he answer correctly. So we figured out that I is equal to 32, which means we also know that 50 minus I is what C is. So the correct answer is going to be 18. So if we go back down there, so our original thing was C is equal to 50 minus I. So C is equal to 50 minus 32, which equals to 18. Right, now that's one way of doing it, right? That's actually rearranging. I'm going to show you guys elimination now. And again, you can, elimination, actually, that wasn't rearrange, that was actually substitution. Sorry, guys. Substitution. And then this is elimination. So with elimination, and I think most people like doing elimination. So that's why, Eliana, I'm going to show you another method to do this. All right. But I think even in that one, you're still going to end up with the same problem of 14, because I'll show you what I mean by. So see how you got C plus I equals to 50, and then you've got 9C minus 5I equals to 2. Now, what you could do is you could actually take this top equation and multiply it by 9, and then you can eliminate C. All right, but the problem is what we're going to end up with is we're going to end up with that same big number. So I would actually say, rather than multiplying it by 9, multiply it by 5, and I'll show you why. Because when you do that, 5 times C is 5C, 5 times I is plus 5I, 5 times 50 is 250. All right, I'm just trying to see, is this going to make it any easier? But I don't think this is going to make it any easier as well, because you're still going to end up with this stupid 14 times table, because what you have at the below it is 9C minus 5I equals 2. And at this point, what you can do is just add the two equations together. So that means I'm just going to show you guys how to do this. So you got 5C plus 9C is going to be 14C. 5I minus 5I becomes 0. And then 250 plus 2 is 252. All right. So what ends up happening is you're actually still going to end up with 14C equals 252. So you still, whether you like it or not, you're going to have to actually work with that 14 times table, Eliana. I'm sorry. I think that's the way this question actually pans out. So once again, you know that 14 times 10 is 140. And then, I mean, I always say, like, do it the other way. Like 14 times 20 is 280. And then you can kind of like go backwards. So what's 280 minus 28? That's actually going to give you 252. So that's like 20 minus 2, which is 18. So 14 times 18 is that. So you can actually say C is equal to 18. I really hope that you guys don't get like I don't think you'll like this question, Jonathan. I don't know where you picked it up from. Was it from an exam paper or a workbook? Because sometimes they do give some horrible numbers in the workbooks, but it's not as bad as this one. Now, Jinlong, I think, look, man, this is the question that he actually gave me, so I don't know where it's from. So, but yeah, you could, like, I know last year's simultaneous equation was just downright horrible, but yeah, that's what it was. Wicked, I did do some quadratics. I think it was, I don't know, man, I think was it on Sunday's tutorial, so just go back and have a look at the tutorial playlist and you'll find it. Okay, Jonathan, I hope that kind of answers your question. What I'll do, I'll actually show you guys a much more chilled out. Oh, it's from the D&D resource. Yeah, those guys, yeah, they tend to kind of just throw in a kind of crazy one every now and then, so just keep an eye on it. All right, so I'm going to go to another question, and this question, what I would like you guys to do is at least try and write an equation by yourself, and then once you write the equation by yourself, you should be able to have a go at this question here. Let's see if that's going to pop up. Yeah, so Sparkles, this clown. You know, what I would like you guys to do is write the equations and then see if you can try and answer it. But I reckon this question is a lot more easier. The numbers are a lot more easier to work with. But just for this question, just be careful with the kind of setup that they actually have. They kind of just throw things around and the order is kind of mixed up. So just be careful with that, all right? And you guys would see this a lot. I actually use highlighters quite a bit in my when I'm explaining things. And that's something that I would actually recommend you guys as well. You know, if you have a few highlighters, just start highlighting things in your questions so you can visually see what's happening with the question. All right, so what I mean by that is in this question, obviously this clown is making balloon animals. We got a first party, Omar's party, he made 2 balloon poodles. So what I'm going to do is I'm going to color the balloon poodles in yellow. All right, and then he makes 3 balloon giraffes. So I'm actually going to put that in green. All right, and then the total of 15 balloons. So I'm going to put that in purple. All right, because if you look at the second question here, for Vivian's party, it says he used 18 balloons. Now 18, the balloons itself, I actually used the pink color. So I'm going to go with the pink color for 18 balloons. For the poodles, I used yellow. So I'm going to go with 3 balloon poodles for yellow. And finally, for the giraffes, I'm going to go with green right there, 3 balloon giraffes. Okay, and finally, the question says, how many balloons does each animal require? Harsh, yes, I am. But anyway, moving on to the question. So hopefully you guys can see the colors there, and it kind of helps you kind of look at the important information for the question that you guys need. Or if you want, you can actually create a table. So you can actually say, you can create a table like this, where you have Omar's party, and then you've got Vivian's party, all right? And then you got poodles, and then you got giraffes, and then you've got the total, all right? So that means for Omar, you've got 2 poodles, 3 giraffes, total of 15. All right, as for Vivian, 18 total, 3 poodles, and 3 giraffes. Okay, so again, with the color schemes there, as you guys can see, the 2 and 3, and I've got the giraffes in green, and the total in purple there. All right, so what I'm going to kind of say is I'm going to put down poodles here as, you know, just put it as P, giraffes as G. Not really going to worry about the total. So what we then have is we've got 2P. This is for Omar's party, plus 3G equals 15. And our second equation is 3P plus 3G equals 18. Now, as I told you guys, I picked a real nice question with the numbers, so it kind of matches up. So in this one, what you could do is you can do elimination straight away. Because the reason why you can do elimination straight away is because if you look at these two values, they're 3G and 3G. All right. So if you want to do elimination, what normally happens is, like I tell people, people actually do this. So they kind of go subtract this entire equation. But instead of doing that, I'm going to show you guys a slightly different trick. If you want to go subtract one equation from the other equation, what you could do is just go in there and just change whatever sign you have to the opposite side. So if you have like a minus, change it to a plus. If you have a plus, change it to minus. So what I'm going to do is 3p is right now positive. So I'm going to change that to minus. 3g is positive. So I'm going to change that also to minus. And then 18 is positive. So I'm going to change that to minus as well. So when I do this, what I'm going to get is, first I'm going to do 2p minus 3p, which equals to negative p. 3g minus 3g is just 0. The equal sign, I don't do anything to it. I just leave it where it is. And then 15 take away 18 is negative 3. Hannah, yeah, it was just kind of like an easy question that I just set up because so people can actually kind of see, how to actually do the elimination, and then yeah, things can get a bit more crazy after that. So what we got is negative p equals negative 3. Rearranging it, we're going to get p equals negative 3 over negative 1. So p is equal to 3. Now if p is equal to 3, you actually got to figure out what g is. So we're just going to use one of these equations. We're going to use 2p plus 3g equals 15. What we have is 2 times 3 plus 3 times g equals 15. 6 plus 3g is 15. And then we've got 3g equals 15. Take away 6. And 3g equals 9. And g is equal to 9 over 3. So giraffes is equal to 3. Oh, did I mess that up somewhere? We got 3 for poodle and 3 for giraffe. I think I've got someone with that answer there. Sweet. So guys, yeah, I mean, like this was, as Hannah was actually saying, it is just a really simple question just to show you guys how to set up the question and then how to kind of solve it. All right. Okay, so now to go into something a little bit different, I want to go to that second question that was sent to me by one of these guys on Facebook. So this is actually this is not simultaneous equation, by the way, this next question that I'm going to do, but it is it has a lot of elements in terms of learning how to construct equations. All right, and I would say it's a pretty kind of like a, taking all this information and then putting it into a linear equation is a bit of a task, but we're going to kind of try and work this through. All right, and I'm going to show you guys how to break this question down into a linear equation and then kind of solve it. All right, so what we have is basically we got Jasmine worked at the ice cream parlor, summer holidays, yeah, whatever. All together she worked 250 hours. So there's our first bit of information that's quite crucial. All right, so she actually worked 250 hours. The next bit is like most of the hours she worked was spent making ice creams. Again, however, she also worked. So basically she's got like 3 jobs because she spent some time making ice cream. She worked in the till, which I'm going to put in a different color. So she's worked in the till, and then she's also spent some time making some chocolate dip for the ice creams as well. Okay, so again, 17th and 19th. Okay, so what I've got is I've got like these 3 different kind of events that are happening: making ice cream, working the till, and chocolate dip. And all of that equals to 250 hours. Okay, so basically this is what we have. We've got something in blue, that's the ice cream, plus something in green, which is the till, plus the purple, which is the chocolate dip, which equals to the yellow, which is 250 hours of working time. That's what we have so far. Okay. Guys, could you just a bit of a favor? Could you keep the chatter to the minimum on the side in terms of apart from questions, because it makes it really hard for me to keep track of both things when I'm doing questions and looking at, if people put up questions, I can't actually follow it. So yeah, anyway, that's all right. Let's just keep going. So what do we got here? So the first thing is that it says she works 90 hours less on the till than she did making ice cream. All right, so this is the making ice cream part, and on the till she actually works 90 hours less on the till. So that's the kind of like the first thing that I'm going to do here. So what I'm going to do is I'm going to put down X, and I'm going to call this as hours making ice cream. All right, so the reason why I want to do this is because this is one of these questions where it's like using the first hour connection with the second hour connected to the third hour. So right now what I've actually said is X is hours making ice cream. So that's actually the blue part here. All right, so I'm going to put that down as X. Now the green part, this is on the till. So on the till, she's actually working 90 hours less than she did making less than on the till than she did making ice cream. So whatever X was making ice cream, she actually worked 90 hours less than that. So this is the green part right here. So the green part is actually going to be X minus 90. All right, and then the last bit is trying to figure out the purple part. Now the purple part actually says this: 2/3 of the time she spent working on the till, so was used to make the chocolate dip. So 2/3 of the time she worked on the till was for the chocolate dip. So that means I got another equation here. So this is for the chocolate dip. So 2/3 of till. But we know that the till, what she did in the till was actually X minus 90. So it's actually 2/3 of X minus 90. So this is actually what is worth for the pink part. All right, now I realize I've actually kind of written it out quite small, but I'm going to try and fix that. So we got 2/3 of X minus 90. All right, so let me just kind of rewrite that. So I've got X, which is the hours making ice cream, plus X minus 90, which is the time she worked on the till, plus 2/3 of the time she worked in the till, and all of that is equal to 250. Taranjot, what I would recommend you to do is have a look at, I think it was Sunday's tutorial. So if you go into my main page, you're going to see all the tutorials that I've done so far this year, and I've done a few quadratics, which is less than 0 and greater than 0 and things like that. So today I'm just focusing on simultaneous equations, but yeah, there was an entire hour that I spent on Sunday doing those, doing quadratics. So have a look through there. All right. Okay, so let's actually go through this, and we got to try and work this out. So what we've got is X plus X minus 90 plus 2/3 times X is going to be 2X over 3, and then 2/3 times minus 90 is going to be negative 60. And all of this is equal to 250. All right, so now we got to collect all our like terms. So what we have got is X and X, which is going to be 2X plus 2X over 3, and then I've got minus 90 and minus 60, which makes minus 150, and that's equal to 250. Okay, one more thing, 2X plus 2X over 3 equals 250, minus 50 when it goes to the other side becomes plus 150, and so what I've got is 2X plus 2X over 3 equals 400. Right. Why is it 2X over 3? Because what I've done is I've taken 2 here and I've multiplied it with X. So 2 times X is 2X, and then in the denominator is just going to be 3. So that's how I get 2X over 3. So I've just expanded that bracket, really, that's why. But Sujan, just remember that it's actually, there is a 3 right here. I'm just going to color it in a different way so that you guys can see it. So that 3 there So 180 divided by 3 ends up giving me that 60 there. Okay, hopefully you guys got that part, and I can just keep carrying on. So what happens now is, right, this part here, I've actually got to combine it together. And for me to combine it together, I need both of the denominators to be the same. Now for 2x has a denominator. 2x has a denominator of 1. So if I want to change that denominator to a 3, I've got to multiply the denominator by 3 and the numerator by 3. So what ends up happening is I've got 3 times 2x, which equals to 6x over 3, and then plus 2x over 3 as it is. And then on this side, I've got 400. Now, 6x plus 2x is 8x over 3 equals 400. And then I can rearrange this and say that 8x is equal to 400 times 3. Now I'm going to give you guys a bit of a, well, actually, no, it would still work out. So we're just going to go 8x is equal to 1,200. And then x is equal to 1,200 divided by 8. Could you multiply 400 by the 3 denominator? Shouldn't 2x... Okay, shouldn't 2x over 3 minus 60 be 2x over 3x minus 60? AEV not Beck. Basically, when you actually expand fractions with x, so I'm just going to kind of show this on the side here, just to kind of clear your question there. So you're basically asking, why is 2 over 3 times x not 2x over 3x? All right. Now the reason that's actually incorrect is because, remember, x, when you multiply fractions, right, x is actually has got a 1 below it, but we just don't write it. So it actually looks like this, because in other words, it's going to look like this: 2 over 3 times x over 1, but we just don't write the 1. So what ends up happening is 2 times x is 2x, and then 3 times 1 is 3. So that's why it's actually 2x over 3. 2x plus 2x. AK life? No. Definitely no, you cannot do that. You can only do times 3 if everything on the left-hand side has got a denominator of 3. So that's one of the main reasons I'm actually doing this step right here. Okay, because that original, the first 2x doesn't have a denominator of 3. It's got a denominator of 1. How did you get the minus 60? The way I got minus 60 was, if I go back here, let me see, I'm just running out of colored pens here. Let's see, red, let's use red. So I actually went 2 times 90, which equals to 180, and then, but it's 2/3 times 90, right? So let me just show you guys, I'm going to show you guys here. 2/3 times negative 90 is equal to negative 180 over 3, which then equals to negative 60. So AKL life, Auckland life. Basically, the question that you asked with that whole kind of going 2x plus 2x equals 400 times 3, it's a common mistake. A lot of year 11 students who don't understand, like who have kind of like have difficulties with fractions, they actually make that mistake quite a lot. So the only time, and I think that's why I'm actually showing you guys this particular step here. So this step here is really important, because what it does is it actually combines the two denominators together as one denominator, and then you can actually move 3 across. Now in the process, we actually haven't finished the question. So we've got x equals 1,200 divided by 8. So now again, like, look, this is a pretty big number. You're thinking, if you're not good with your what do you call it, times tables, then what you can do is know that 12 can be divided by 4. So when it's divided by 4, it can be written as 3 and then 2. So this could be rewritten as 300 over 2 Now that's a lot easier to do. 300 divided by 2 is 150. Aliana, I have actually seen a question like this before in mocks. I can't remember seeing a question, but you know, I can never know, man. I mean, like, people, they ask questions like this. Now guys, honestly, this is not a how do I say it? I know it looks like a lot of work, but I think the hardest, there's only two parts that's really kind of like important. The first part is actually coming up with the equation. All right, because once you come up with the equation, then everything is just kind of like learning, just using the skills you've already learned. And the second challenging part is this part right here, like making sure you expand it correctly. And then the third part is this part here, where you understand that the fraction, doing the fractions correctly. Yeah, that's actually another way you could do as well, Sarah, like 8 times 100 and then 8 times 50. You know, it's Daniel, you asked me that question. It's like I guess like, you know, we used to, like, you know, when I was studying this, like I used to be able to do like things like long division, which you guys don't do anymore, which kind of sucks, because if you know how to do long division, it's pretty much straightforward. But yeah, so I would actually say, like, I mean, I'll show you guys another way of doing this. For x as 1200 over 8, what you can do is you can rewrite this as 4 times 300 over 8, and then you can just kind of say, well, 8 is actually a multiple of 4, so I can cancel that and write that as 1 and write that as 2. Now if I went, let me actually show you another method as well. So what you could do is like this, is instead of writing it as 8, write it as 4 times 2. Then what happens is both the 4's cancel out, and what you're left over with is just 300 divided by 2, which is a lot easier to do, which is 150. Yeah, it's really I think for you guys, like, you know, don't look at it as a lot of work, because this type of question usually ends up being like a merit or an excellence question. But there's a lot of things that guys can actually do to get to a merit, even if you, like, say you make a tiny mistake. Like, for example, it was you know, not A.V. Beck's mistake. A.V. Beck's mistake is pretty brutal, but I'm talking about Sujan. Like Sujan, if you made that mistake of saying it was 2x minus 180, you could still get, like, as long as your working is correct, you can get some consistent marks for it. So that's why don't stop a question, like just keep going as far as you can get the answer. All right, guys, let's go to the next question. So this was a question from 2017. It was a very similar question. I might just give you guys maybe like a minute or two just to have well, not a minute, I'm just going to give you guys some time to have a look at it. If you do have any other questions, just pop it in the chat and I will kind of just answer it as we go along. Yes, that's exactly right, Daniel Clayton. Do you want me to show it to you? Yep, that's exactly it. So if you can use that, man, you can definitely use that. If you're comfortable with it, just use it. Sweet. Okay. All right, guys, so let's get with this question here. So what we have is, I mean, you know, of all the simultaneous equations that I've actually seen in the past few years, I actually thought this one was the most straightforward simultaneous equations I'd seen from, who do you call it, from NCEA in a very long time. Because all you really have to do is just rearrange this question and off you go. So show you guys how this actually works. So we've got 3x minus 2y equals 5. What I'm going to show for you guys, this particular question, I'm going to do it in, let's see, what should I do, substitution or elimination? I'm actually going to do substitution here, just so that you guys have, actually, you know what, I'm actually going to do elimination. Let's do elimination. So what I'm going to do is I'm going to write that second equation down, but I'm going to write it with x in the front. So it's going to become 4x minus y equals 10. I hope I actually got this question right, because something doesn't feel right. 215, yeah, no, it should be all right. Okay, so once I do this, I've got to decide which letter I want to eliminate. All right, now I'm going to give you guys a bit of a heads up. Looking at this, most people go, oh, I want to eliminate x straight away because that's the first thing that's actually in front. Always take some time to look at all your coefficients. When I say coefficients, I'm talking about these numbers here. So you got 3 and 4, and then in this case, you've got -2 and -1. All right, you want to try and minimize the number of number of times you actually multiply these equations. So what I'm saying is that just multiply this equation here by 2. The reason is because that means that -y now, so this part here, when I multiply it, will become -2y, and then it just becomes really easy. Can you rearrange -2 with the signs change? No, Jonathan. Because 4x minus y is on the same side, the signs won't actually change. So it's kind of like this. Think about it like this, all right? You know, if I have like -2 plus 5, this is equal to +3, right? This is the same thing as saying 5 minus 2, because it's equal to 3. Legendary, I will do the substitution method on the side as well, all right? When it's on the same side, you can actually switch numbers around, but just remember that the symbol to the left of the number goes with it. So that's why I haven't actually shifted 4x minus y to the right-hand side. I've just kind of moved it around in that same left-hand side itself. Okay, so the reason I want to multiply this by 2 is what I end up getting is 4x times 2 is 8x, minus y times 2 is minus 2y, and then 10 times 2 is 20. So, and then below it, I'm going to write my first equation, which is 3x minus 2y equals 5. And remember, what I want to do is I want to actually subtract this equation, subtract the second equation from the first. So what I'm going to do is in this second equation, I'm going to just go ahead and just change the signs. So basically, I'm going to change 3x to a minus, minus 2y, I'm going to change to a plus, and then +5, I'm going to change to a minus. Why is your first equation on the bottom, not top? Order matter. Jonathan, the order does not matter. You can actually put the order in any way and you would still get the same answer. So that shouldn't, don't worry about the order of which equation you put on top and which one you put at the bottom. Okay, Daniel, I don't think you've actually answered the question correctly. So when I say that, look at this part right here. But anyway, I think you're almost there, mate. Like, you just got to make sure you get that final answer right, the value of x plus y. But anyway, let's kind of do this. So what we have got here is 8x minus 3x is going to be 5x. Negative 2y plus 2y becomes 0. 20 take away 5 is 15, which means x is equal to 15 divided by 5. So x is equal to 3. Why do you switch the signs? Okay, I'm switching the signs because I want to eliminate one of the variables. Because remember, this was my original equation. My original equation was, I had 8x minus 2y equals 20 and 3x minus 2y equals 5. Now, if I actually subtract this, then I've got to subtract it, and so when I'm subtracting it, that's why I'm actually changing the signs. So it makes it easy for me to actually subtract the two equations from each other. Okay, anyway, so we've got x equals to 3. I need to figure out what y is. So I'm going to pick one of these equations. I'm going to pick the second one right there, which is 4x minus y equals to 10. So 4 times 3 minus y equals 10. I've got 12 minus y equals 10. And you can guys, I mean, like, you can do this the long way if you want to, but you can actually do the shortcut as well, because you can just go y is equal to 2. But just in case, I'm going to go negative y is equal to 10 minus 12. Negative y is equal to negative 2, and then y is equal to, therefore y is equal to positive 2. All right. Now, as I was mentioning to Daniel before, Daniel actually said x equals to 3 and y is equal to 2, I think. Well, he's absolutely correct. But if we go back to the question, and this is exactly what so many kids did in 2017, they actually didn't answer the question. The question is actually find the value of x plus y. So you have to write a statement at the end of it to say, therefore, let's actually go back down, x plus y is equal to 3 plus 2, which equals to 5. Oh, no worries, mate. No worries, Winter Soldier. I'm here to just doing a bit of work. All right, Legendary asked me to actually do this in the substitution method. So I'm going to do this in the substitution method now. So let's go back. Same question, but substitution. All right, so with substitution, I want to actually, so I've got 3x, just get rid of this. 3x minus 2y is equal to 5. And then I've got negative y plus 4x is equal to 10. Now, Legendary, what you want to be doing is you want to actually minimize dealing with fractions, okay? You don't want to be dealing with fractions. You want to do like a straight substitution. So to do that, the best option would be is to rearrange so that you can have a positive y, because then you can just substitute it straight away into the first equation where there's a y. So with the second equation, what I'm going to do is I'm going to rearrange it. So I'm going to get, just bear with me on this, I'm going to get 4x equals 10. When I bring y over to the right hand side, it becomes plus y. And then in my next step, what I'm going to do is 4x, and I'm going to bring the 10 over to the left-hand side, it becomes minus 10, and that's equal to y. So basically, I have 4x minus 10 equals to y. So that means this yellow part, the y being yellow, I can actually replace it here. So when I write my first equation, remember my first equation was 3x minus 2y equals to 5. But what I've done is I've rearranged so that, well, I'm going to substitute the y now. That's what I'm going to try and do. So, and I've already shown that y is equal to 4x minus 10. So then I can say 3x minus 2 times 4x minus 10 equals 5. So all I've done is I've actually substituted y as 4x minus 10. So now it just becomes your regular mundane thing of just expanding the brackets. So we've got 3x minus 2 times negative 4x is minus 8x. Negative 2 times negative 10 is positive 20. And that's equal to 5. So 3x minus 8x is negative 5x. Plus 20 equals 5. Negative 5x equals 5 minus 20. And then you got negative 5x equals negative 15, and x equals negative 15 divided by negative 5. Which means x is equal to positive 3. Now, once you get x equals to positive 3, we know what y is equal to, because y is equal to 4x minus 10. So then we can just go 4 times 3 minus 10, because remember, we said that x is equal to 3, which means we're going to replace this x with 3. And so what you end up getting is 12 minus 10, and you get y is equal to 2. And then, of course, don't forget x plus y equals 3 plus 2, which equals to 5. So you can do either method, guys. Thanks for the compliment, Harsh. Happy to help, man. So yeah, you can do either method, guys. Like, I always say, like, just practice. That's all you got to do. All right. And I think that's the beauty of it. And also, one more thing: when you do simultaneous equations, when you get your final answer, go back to it and just try it out. Try it in the equations to see if it actually works out. So what I mean by that is, see right now how we said x is equal to 3 and y is equal to 2. Let's actually substitute that. So we've got 3x minus 2y equals to 5. So if we go 3 times 3 minus 2 times 2 equals 5. 3 times 3 is 9. 2 times 2 is 4. And is 9 minus 4 5? Yes, that's true, which means your two answers are actually correct. Okay, let's see. Where are we up to for questions? Dear Patel. Why do I recognize this name? Seems like this method is a lot more work. Dominic, basically it's just up to people's preference, man. Like, you know, with the elimination, you've got to be a bit more kind of savvy about what you want to eliminate, because I know, like, an elimination method, you can actually do things where things end up being very long as well. But yeah, ultimately it's just like practice both of these methods and you're pretty much good to go. Cools, how many tutorials am I doing? Cools, I am thinking of doing like maybe another one every now and then. Just keep an eye on it, eye on my channel, guys, because some days I'm just exhausted and like probably just crash at 8 o'clock. Some days I'm sitting there, like I can run tutorials for like 2 hours non-stop. So it's not a, so just keep an eye on it. I think the next one I'll try and do one on Thursday night. What are I'm in year 10. This is helpful. You're welcome. No worries. There are complex numbers. I'll probably do. Sorry, man. I don't think I'll have time to do it before the mocks, but definitely before the end of year exams, I'll be going a bit crazy on tutorials. Just something to do for me later on. All right, guys. This was the question from 2017. Yes, like so just read the question and see how much information you can actually get out of it. Now, I had a look at the 2018 simultaneous question, and that was, in all honesty, it was brutally harsh. That's all I can tell you. But you know, I really hope that they don't actually give a question like in 2018 for simultaneous equations, because what's funny is that, like, in 2018, like, you know, like the same question that came in 2016, which was an excellence, they converted that to a merit in 2018. So yeah, but they always change the schedules as well, so it's really hard to predict how they would ask, like, some of the questions that they ask. Okay, so the last question for the day is this simultaneous equation question. Now, this has given grief to quite a few students a few years ago, so that's why I've actually brought this question back. It is a simultaneous equation question, but I think the hardest part with this question is actually setting up the equation. Because once you set up the equation, then things become just so much more easier after that. Just give me 1 second. I just want to grab. Where we at? We got couple of more questions popping up. Okay, so I want to try and do this question here, and then I'll try and hit. I'll see if I get some time to do the other two questions as well. So this is just a very you kind of almost have to visualize this question first. So the way I do this question is, like, I kind of just put down Andre here first and then Bob. All right, so what I'm going to do is I'm going to put down A as whatever money Andre has got, and B for whatever Bob has actually got. So the first sentence, or the second sentence, it says, if Andre gave Bob $20, they would have the same amount. Okay, so I guess the way to look at it is, if Andre gives $20, so that means Andre's actually lost $20, and then if that $20 goes to Bob, then Bob has actually gained the $20. That means now they've actually got the same money, same amount. Oh, you're welcome, Krish. No worries, man. I'm sure you did most of the work. I didn't do anything. So yeah, so that's the first equation to kind of have a look at, all right? So if Andre gives $20, then whatever the new amount he has is the same thing as Bob when he's actually gained 20 bucks. As for the other way, so this is basically looking at Andre giving $20, Bob has gained $20, and now they've got the same amount of money. So that's your first equation, sorted. Now the second equation is, if Bob gave $22, so Bob is actually giving Andre $22. So I'm going to write that down first. So if Bob gives $22, so this is the second equation now, which means Bob is losing $22. Andre is actually getting $22. But then it says, then Andre would then have twice as much as Bob. So in this case, whatever Bob has, Andre's actually got twice of that. All right, I hope that kind of made sense there of how I actually did that. So basically, I'll just try and explain to you guys again. So this minus 22 is when Bob actually gives, so he's actually lost $22. This plus 22 means Andre's actually gained $22. And then it says the twice as much. So this is twice the amount Bob has, which Andre actually ends up having. So Andre actually has twice the amount as Bob. Why did I put it in brackets? Because it's 2 times the total amount of whatever Bob has. Cool. Good to know, Cools. Legendary, did you get that, man? So basically, it's twice the total amount of whatever Bob has. So Bob's actually lost 22 bucks. So that means we've got to double that. That's why I've actually put that in brackets. All right. Once you get that, we've actually got 2 equations. Here's our first equation. Actually, no, I'm not going to write that here. So these are my 2 equations. I'm going to sort out my first equation. I've got a minus 20 equals b plus 20. Now this one, there's no elimination or anything. Substitution is the way to go in this, because what you can do is a is equal to b plus 20, and then I've got plus 20. So I rearrange it. I mean, when I write it, it becomes a is equal to b plus 40. So once I get this, because a is equal to b plus 40, I'm going to replace a with b plus 40 in the second equation. So this is my second equation now. My pen is dying. So my second equation was a plus 22 equals 2 times b minus 22. All right, now I know that a is equal to b plus 40, so I'm going to replace that. So I got b plus 40 plus 22 equals, expand the brackets, so 2 times b is 2b, 2 times negative 22 is negative 44. So at this point, I've got to rearrange things again. So what have we got? I'm going to bring 40 and 22, I'm going to leave it here, so it's going to become 62 equals 2b minus 44, and shifting the b to the right hand side, so it becomes minus b. So what I've got left over with is 62 equals, now 2b minus b is just b minus 44. So rearranging it now, b is equal to 62 plus 44, which means b is equal to 106. There's always a year 13 that comes and trolls us in this level 1 tutorials. Anyway, so we've discovered that Bob actually has got $106, which means Andre now has got b plus 40, which is 106 plus 40 equals 146. Now guys, it is like at this point you can actually check your working. All right, if you go back, we've actually said that Andre is getting $146 and Bob is actually getting $106. Now if you look at these numbers, it actually makes sense, because look, if Andre actually gives $20 to Bob, then Bob goes to 126 and Andre actually drops to 126 as well, which means they will have the same money if Bob actually gives 20 bucks. If you do it the other way, so if Bob actually loses $22, then he actually has 106 minus 22, which is going to be $84, which means Andre is actually going to gain $22, which ends up being 168. And you can see that 168 is double that of 84. You're welcome, RCHX. I didn't realize I helped you for both years. Okay, guys. That's pretty much all the questions I have for today's session. What I will do is, I know I have actually got this OneNote as a public page. I'll share it in the comment section later on once the video is actually uploaded. And so you could actually look at all of all of the tutorials that I do. They're literally just here in this OneNote. This is basically my whiteboard that I use for my classes and for tutorials. It has all the exam papers, so you guys can just access this and just have a look through it, because I know sometimes I kind of write the questions and just move it up real fast. Okay, so when I actually upload this video later on, it will have the link to this OneNote, and you guys should be able to actually navigate it through it and find where the questions are. Okay, sweet. That's it from me, and I'll hang around for a few minutes as usual. If there's any other extra questions, feel free to kind of put on the chat section. Yeah, no worries, guys. As always, here to help. Yeah, I would actually go with Aliana's advice. Just practice, practice, practice. Now, what does your name mean? It's a very long story, Rajat. I probably need to run a live tutorial for that. So did you cross multiply for the 3/3 in question 2, I think? 3/2 in question 2. Is this the ice cream question, Selena? Saran, I probably will be doing it on Thursday for level 1. I need to do one for level 2. Taranjot, I think I'm gonna pop by and talk to some of the kids there at some point in the next few weeks. I had a chat with Mr. Dada about it. So Selena, yes, going back to your question, sorry. Where am I going for cross multiply for the 3/3? Are you talking about the 8x/3? Cools. Please feel free to share this channel to you, folks, because I have a little bet going with my some of my students that I can't reach a particular number of subscribers, but more than subscribers, I'm just happy to help out people. 3/3 times 2x. Oh, there. Right. So did you cross multiply for the 3/3? No. So the reason I did that 3/3 times 2x/1 is because, see, when you have, I'm just going to do that separately at the bottom, right? So just bear with me. So this is the question you're asking, right? So right now, this is what I had. I had 2x plus 2x/3. I can't actually combine them together. The reason I can't combine them together is because 2x actually has a denominator of 1. All right, so that's why what I'm doing is I'm multiplying the denominator by 3 and the numerator by 3. So basically that means 3 times 2x is 6x, and then 3 times 1 is 3. Does that help, Selena? Man, RCHX, you've known this for 2 years, and no wonder my numbers have never gone up. David Lee. Do I know any of you? I'm not sure, Taranjot. I know I was supposed to come for something, but I'm not sure exactly what it is. Because I'm at the moment, I'm just going around schools, just helping out. Well, not helping out, just giving some talks on Space Camp. Because I actually want more students from New Zealand to figure out a way to get to Space Camp. Aliana, that would be awesome, man. Would love it. Yeah, I'm happy to help out. Which area are you from? Are you from? Do you think you could do a live for level 2 calc or algebra? David Lee, it is coming. The only reason I'm actually spending so much time with MCAT is because MCAT's in about 2 weeks' time, and I will be doing a live tutorial for algebra level 2. And then I might do level 2 calculus later on. Yes, but still kind of confused. Okay. What about this, Selena? Let me put up another question. So say you got something like this. 3x plus say you got 3x plus 4x over 7, right? So what happens is you can't actually combine these two together, because if you think about it in fractions it's like this. Imagine if there's actually no x, right? Then you've actually got 3 plus 4 over 7. Now you can't actually add this together. The reason you can't actually add this together is because 3 is a whole number, 4 over 7 is actually a fraction. Yeah, Sarah, except I would strongly recommend staying away from the upside down picnic table. The reason I'm saying stay away from it is because it kind of messes you up when you start dealing with algebraic equations. It actually makes it a lot more harder. Yeah, so in this one, it's actually 25x over 7, because what we're doing is, because 3x can be written as 3x over 1, we want to have the same denominator, so we're going to multiply it by 7, the denominator and the numerator by 7. So what you end up with is 21x over 7 plus 4x over 7, which ends up giving 25x over 7. Now I want to show you something else as well. You know, you got 3 plus 4 over 7. If you actually do that in the calculator, just to kind of show you quickly. So if I get 3 plus 4 over 7, you actually get 25 over 7. So it's just another way of saying 3 in mixed numbers. It'll look like 3 to the power of 4 over 7. So you could always just multiply the denominator whenever you have the whole number in a fraction. Yes, you can. Because whenever you have a whole number, it can, like in a fraction format, it'll just be like 3 over 1 or 4 over 1. If 4 is like a whole number, then 4 over 1 is like in the fraction format. Sarah, what do you mean by negatives? I don't like negative linear equations or quadratics or exponentials. Mr. Clo, I have no idea. Oh, yeah, I know which one you're talking about. Okay, subtracting fractions. Yeah, we can actually go through that. Next time around, we'll actually do some fraction questions which have minus in them. Yep. I get what you're trying to say. Yeah, so like Selena, with the when you're dealing with fractions, it has the same rules as numbers. So, the only difference is it has an x. In fact, you could have done that question like this. Because x is like a common factor, you could almost take x out like this, because 3 times x is 3x, and then x times 4 over 7 is 4x7. So in fact, you could have done it like this as well. So it still has the same kind of ideas behind it. Aliana, I'll tell you a crazy story last year. Last year I actually predicted a question that was going to come, which was just nuts. Like literally on the day before the exam, I think I actually came up with this really crazy question, and I thought, there's no way they'll ask a question like this. And then I put it up, and then the scariest thing was that was almost number for number. It was literally the same question that actually came up. You can meet with an algebra question. I don't understand that question, David. Taranjot, I don't actually have an Instagram page for Infinity Plus One. Maybe I should actually create it and put a story up or something like that. Maybe something for the future, man. It's just so much social media you can actually kind of keep up with. All right, guys, I'm gonna leave you guys to it. I'm gonna go watch some YouTube, I guess, or some random stuff that's there. But yeah, I'll actually put the video up shortly, and come back on Thursday. Thursday will actually, if you have any questions, I think at the moment I've got some people asking questions for fractions. So happy to do some fractions. Word problems, Harsh, if you put some word questions on my Facebook page, man, I can actually answer it, because what I do is I basically just go and collect questions from students like this, and yeah, it just makes it easy for me to actually kind of answer. So I think this is my, I actually picked up a couple of questions today from tutorials. Wicked, you gotta listen, man. Here's all my quadratics. This was from my last tutorial that I did, Wicked. All right, so head over to look up 1st of September, the tutorial from 1st of September. There's a lot of quadratic questions there for you to actually do. Okay, let's see. I always struggle with actually trying to shut this thing down, but okay, so quadratics next time. Clothing MCAT. Oh yeah, no worries, Wicked. So I actually created a playlist. If you go to my, let me see if I can show you guys. Give me a second. Wicked, where is Wicked? I'll just show you where all the stuff is, so it makes it easy for you, so you can kind of see it. So Wicked, if you actually go to my main page, there's a section here called NCEA Level 1 MCAT Algebra Tutorials Live. So if you go there, you would actually see all the tutorials I've done this year so far, and I think that's the 1st of September one. So if you go there, you'll find some of my previous, the last 2 tutorials work, so you can actually have a look through it, and there's also tutorials from last year as well. So you can have a look through it. And this playlist here, the MCAT preparation, there's about 107 questions there. Yeah, and that has a lot of different styles of question that you could potentially look at. Aliana, you'll have to do algebra for calc next year. I don't think you can just take calc. Okay. Yeah, that was a longest 2 minutes that I've ever spent after a stream. Alright guys, I'm done. See you on Thursday.